So today in this video we are going to discuss about the topic types of fluid flow, which comes under the study of kinematics of fluid flow. Okay, as I have said earlier, kinematics of fluid flow is the branch of fluid mechanics which deals with the motion of the fluid particles without considering the forces causing the motion. Okay, so now starting with the classification of the types of fluid flow. First is steady flow and unsteady flow. Okay, first classification of the type of fluid flow is steady flow and unsteady flow. So the steady flow is defined as that kind of flow in which the properties of fluid does not change with respect to time. Okay, properties of fluid does not change with respect to time, while in case of unsteady flow, properties of fluid changes with respect to time. We have discussed earlier that what are the different properties of fluid. It includes velocity, density, pressure, etc. So these are the properties of fluid which are not changing with respect to time in case of steady flow. Okay, if I'll give you an example, that if 2 meter per second, if water is flowing with a velocity of 2 meter per second in a canal at 10 o'clock. Okay, and if we observe the velocity of the water in the canal at 12 o'clock, then again if it is 2 meter per second, it means that the velocity has not changed with respect to time. It was 2 meter per second at 10 o'clock and it was also 2 meter per second at 12 o'clock. So it is not dependent on time in case of steady flow. Okay, but in case of unsteady flow, if the velocity of fluid is 2 meter per second at 10 o'clock and if it becomes 1.5 or 3 meter per second at 12 o'clock, then the velocity is changing with respect to time. Okay, it is dependent on time. So it is a case of unsteady flow. Are you getting it? Okay, so steady flow, it is the type of flow in which the properties of fluid does not change with respect to time, while the unsteady flow is a type of flow in which the properties of fluid are changing with respect to time. So mathematically this definition can also be written as del V by del T is equals to 0. Okay, so it means what? Rate of change of velocity with respect to rate of change of time is equals to 0. So the change in the velocity is 0. It means what? It means it is constant, and hence it is referred to as a steady flow. Similarly, we can write for pressure as del P by del T is equals to 0. For density, del rho by del T is equals to 0. So this rate of change of density with respect to time is 0. It means that it is not changing with respect to time. Okay, it is constant. The rate of change is 0. This rate of change is 0. It means that it is not changing and hence it is constant. So mathematically, similarly, for unsteady flow, we can write del V by del T is not equals to 0. Okay, this rate of change is not equals to 0. It is not is equals to constant. It means what? It means that this velocity is changing with respect to time. Similarly, we can write for pressure, del T is not equals to 0, del rho by del T is not equals to 0. So this was the first classification of fluid flow, which is steady flow and unsteady flow. Now moving to the second classification of fluid flow, which is uniform flow and non-uniform flow. Uniform flow and non-uniform flow. Okay, so here properties of fluid does not change. Properties of fluid does not change with respect to space or length of channel. With respect to space or length of channel. Okay, while in case of non-uniform flow, properties of fluid will change with respect to length of channel or space. Okay. So here steady flow and unsteady flow is a function of which property? It is a function of time. Okay. While in case of uniform flow and non-uniform flow, it is a function of space or length of channel. Okay. So if we are considering an irrigation channel or canal, and if the properties of fluid such as velocity, density, pressure, etc. are not changing with respect to the length of channel. Okay, so here if we take again the same example, that if the velocity of the flow in the canal is 2 meter per second at 1 meter length of channel, and at 3 meter length of channel it is also remaining the same, that is if it is again remaining 2 meter per second, then it is known as uniform flow. It is not changing with respect to length of channel. And if it changes with respect to length of channel, then it is known as non-uniform flow. So that at 1 kilometer length of channel, if the velocity is 2 meter per second, and at 3 kilometer length of channel, if the velocity is changing to 1.5 or 3 meter per second or any other value, then it will not be same with respect to length of channel, and hence it is known as non-uniform flow. So this is very important to remember, that uniform flow and non-uniform flow is a function of space or length of channel, while steady flow and unsteady flow is a function of time. Okay, so this must be clear in your mind, that what is the steady flow and unsteady flow is the function of time, and uniform flow and non-uniform flow is the function of space or length of channel. Moving to the third type of fluid flow, which is laminar flow and turbulent flow. Laminar flow and turbulent flow. Okay, laminar flow and turbulent flow. So in case of laminar flow, the streamlines, okay, are parallel and straight to each other. They are moving in well defined path. Okay, as you can see, these streamlines are mostly parallel to each other and they are moving in a well defined path. So it is known as laminar flow, and these are the streamlines representing the flow of fluid. Okay, represents what? Represents flow of fluid. And if the flow is turbulent flow, then in this case, these streamlines will not be parallel to each other. It will move in a random and zigzag manner, as you can see. Okay. So here, these streamlines are moving in zigzag manner, and they are not parallel to each other, while here in case of laminar flow, the streamlines are parallel to each other. Okay, so these are the two other types of flow, which is known as laminar flow and turbulent flow. Now while carrying out practicals or experiments with the naked eye, it becomes difficult to determine whether the flow is laminar or turbulent. Okay, so to determine that, we can use one of the dimensionless number, which is known as Reynolds number. It is represented by the symbol R in the suffix E equals to rho V d by mu, where rho is the density of fluid, V is the velocity of fluid, d is the diameter of pipe in which the fluid is flowing, and mu is dynamic viscosity of fluid. Okay, so RE is a dimensionless Reynolds number with the help of which we can determine that whether the flow is laminar and turbulent, and the parameters which are required in the definition in the formula of this Reynolds number is rho, that is density of fluid, V which is the velocity of fluid, d is the diameter of pipe, and mu is the dynamic viscosity of fluid. Okay, so if the value of RE is less than 2000, then it is known as laminar flow. If the value of RE is between 2000 to 4000, it is known as transition flow. Transition flow means the flow is changing from laminar to turbulent flow. And when if RE is greater than 4000, then it is known as turbulent flow. Okay, so if the value of RE is 2000, it is laminar flow. If it is between 2000 to 4000, it is transition flow. That is, the flow is on the verge to change from laminar flow to turbulent flow. And if the RE is greater than 4000, then it is referred to as a turbulent flow. Okay, so this is again one of the most important type of fluid flow that you will study in detail in your upcoming chapters or in your upcoming subject of hydraulic engineering of the next semester. Okay, so there you can study the detailed what we can say importance of this type of flow in fluid flow analysis. Okay, now moving with the fourth type of fluid flow, which is compressible flow and incompressible flow. Compressible flow and incompressible flow. Okay, so from the name itself you can say that anything which is compressible is known as compressible flow. Okay, or the fluid which is compressible is known as compressible flow. And if the fluid is compressible, then which parameter will not remain constant? Okay, the density of fluid will not remain constant. The density of fluid will not remain constant, that is, rho is not equals to constant in case of compressible flow. Okay, and in case of incompressible flow, rho is equals to constant. That is, the density of fluid cannot be changed. Here it will not remain constant, while here density of fluid will remain constant. So that type of flow is known as incompressible flow. Okay, we are using CNG in cars, so that is a kind of gas or a fluid. Okay, it is a kind of a fluid gas which is compressible, and if the gases which are not compressible, then they are known as incompressible flow. Now the next type of fluid flow is rotational and irrotational flow. Rotational and irrotational flow. So the flow which rotate on its own axis, flow in which fluid particles or streamlines rotate on their own axis, okay, then it is known as rotational flow. And the flow in which fluid particles or streamlines do not rotate on their own axis, then it is known as irrotational flow. So if the flow is rotating on its own axis like this, then it is known as irrotational flow. And if the flow does not rotate on its own axis, then it is known as irrotational flow. Okay. So now talking about last but not the least type of fluid, which is one dimensional, two dimensional and three dimensional flow. 1D, 2D and 3D flow. Okay. So here I am considering three direction, all the three direction x, y and z. Now I am taking one of the property of fluid, which is velocity. Okay. So velocity is taken as a property of fluid. Now components of the velocity in x, y and z direction are u, v and w. Okay. So the component of velocity in x direction is u, component of the velocity in y direction is v and component of the velocity in z direction is w. Okay. So now if the flow is taking place only in x direction, the component of the velocity u will be a function of x only. So here u is a function of x only, while the other two directions are 0. Similarly, if the flow is taking place in y direction only, then component of the velocity v will be the function of y. So here v is a function of 0, y 0. Similarly, z is equals to function of 0, 0, w. Okay. W is a function of 0, 0, z. Similarly, if the flow is taking place in two directions, suppose x and y, so the component of the velocity u will be the function of both directions x and y. So these are the case of 1D flow. And if the flow is taking place in two direction, then velocity component u will be a function of x and y both. Okay. Then v, it will be function of, suppose it is also flowing in xy direction, then it will be also equals to x and y 0. And similarly, if the flow is taking place in v will be the function of y and z. So here x will be 0, y and z. And similarly, w, it will be the function of, if it is taking place in z and y direction, then w will be the function of z and y, right. Okay. So in this way, one dimensional, two dimensional and three dimensional flows can be determined. In case of three dimensional flow, u will be the function of x, y and z, all the three directions. So if the flow is taking place in three direction, then u will be the function of x, y and z. Similarly, for the velocity components v and w. Okay. So I hope that you are clear with the different types of fluids that we studied. So here again we are going to learn about one of the important topics of fluid mechanics, which is rate of flow and continuity equation. So let us see first of all that what do you mean by rate of flow. Okay. So rate of flow, it is defined as the volume of fluid flowing per unit time. Volume of fluid flowing per unit time. It is denoted by the symbol Q and it is also referred to as discharge. Okay. So discharge is nothing but volume V per unit time T. Its unit is meter cube per second. Okay, clear? So rate of flow is defined as the volume of fluid flowing per unit time. Volume by time, and its unit is meter cube per second. Now let us understand that what is continuity equation. So here I am drawing a two section of say pipe. Okay, this is suppose section 1 and this is suppose section 2. Now fluid is flowing through this pipe. So the whatever amount of volume of water is entering to this section of pipe, same amount of water will leave through this section 2 of the pipe, and it is based on the law of conservation of mass, or here we can say volume. Okay, so whatever amount of volume will enter through this section of pipe, the same amount of volume, the same volume of fluid will or water will leave through the section 2 of the pipe. So writing some equation at section 1 and at section 2, that is the volume rate of flow at section 1 is equals to volume rate of flow at section 2. Okay, so volume is nothing but area into length. So A1 L1, and at section 1 is equals to volume rate of flow at section 2. So it is nothing but A2 into L2 at section 2. Now if I divide this equation with respect to unit time, that is T1 and T2. Okay, so here this L1 upon T1 will become what? Length upon time, distance upon time, it will become velocity. So A1 into V1 is equals to A2 into V2. V2 in place of this L2 divided by T2, because distance upon time is nothing but velocity. So A1 V1 at section 1 is equals to A2 V2 at section 2, and this is known as continuity equation. Okay, this is known as the continuity equation, and this equation will be very useful in the understanding of Bernoulli's equation. Okay, the Bernoulli's equation which you will study will be easily understood if you are clear with the concept of the continuity equation. Now I want to add something over here, that here if the density of the fluid is constant, then this equation will appear like this. Okay, because density is constant at both the sections. But if the density of water at section 1 and fluid and density of fluid at section 2 is getting changed, okay, and that is possible if the two different fluids are present. So if that case appears, then this equation will become rho 1 A1 V1 is equals to rho 2 A2 V2. But this case is mostly not possible. Okay, so as we will generally consider only one type of fluid. Okay, so here mostly in most of the cases the density rho 1 and rho 2 will be same, and in that case rho 1 is equals to rho 2 is equals to rho, and our equation will become this, which is A1 V1 is equals to A2 V2.